I'd love to give a demo of what we do at Samsara to give you a little bit more taste of practically like how do customers use the technology we develop, and then open up from there, talk through some of the technology pieces, and then really do a little bit more dynamic presentation for like the last 15 or 20 minutes. So I'll start taking questions then, but would love to kind of dive into different areas. I and to give you guys a little bit of background, I had been a PhD student like long ago. I was working on computer networking, and that was my background. So, the first company I started was focused on that. I think as we got exposed more to how things work out in the world, and the companies that kind of run the physical infrastructure, uh, that kind of hit a chord with me. And when we after our first company got acquired, Meraki spent some time looking around, going out and visiting customers that we had gotten in contact with through Samsara, and really ended up starting the company to actually have a large impact on those type of companies. It seemed a little bit different. Just coming from an academic background, it was really interesting to us to go through and try to figure out like exactly how these companies worked, the processes they used, and really how they get all the things that go into everything from delivering food, creating infrastructure in our economy. That stuff was like really fascinating. So I'll walk through a couple of examples of that. It is pretty reflected in our mission. So we talk a lot about safety, efficiency, and sustainability. And those are the three applications we'll work on. I'll spend a lot of time talking today about the safety applications and give you guys a concrete example of like what this ends up being. These are some examples like when we got started. So basically, those were some of the first versions of the internet gateways that we end up making. Those on the right have evolved into a product, and I'll explain exactly how they work. These are the different applications that we end up having in construction. They might be in food delivery. They might be a propane company that's out actually like delivering propane and natural gas to their customers. We partner with them. They will usually go out and might have anywhere from 500. The larger utilities that we do business with have tens of thousands of vehicles that their employees drive to job sites and things like that. We package up some hardware for them. So most of the vehicles have a combination of a dash cam, which is this guy right here, that usually goes up in the cab. There's usually either built into the dash cam or kind of as a secondary device, a smaller telematics unit. So the way to think about this is like a cell phone that's kind of packaged up, just an industrial version of it that fits in the vehicle. It has cell modem, has an IMU, and then it connects to the onboard processor on the vehicle. There's usually a CAN bus on there where you can read out all the diagnostics from the engine, fault codes, and things like that. That in combination with the dash cam that's running, dash cam usually has the IMU, it usually has a GPU. It's not a large NVIDIA, but we've seen a pretty big jump in what people will need. It's kind of like a pixel device just in terms of capabilities. So these units out in the field are usually attached to a vehicle like this. These stream back to the internet and then allow these companies, if you can imagine, they're responsible for managing thousands of these vehicles. Usually one of their very large costs are safety-related expenses that they incur. So this might be somebody gets in an accident, and they usually, through the technology that we have, we enable them to run very large safety programs so that they can drive that number down. Just to get kind of like concrete, so it gives you guys an idea, like if you have 1,000 or 2,000 vehicles, a company like that might end up spending anywhere from $5 to $15 million a year on accident-related costs. So that might be everything from like they actually get into a crash and there's a lawsuit from it. It could be the downtime when they have to take a vehicle out of service and redeploy it. It could be just the delays in the jobs that they were running. It costs them real money. What we end up doing is installing these devices and help partner with them to run a safety program to help drive those accidents down. that makes sense. And it's one of these things, like in order to run a program like that, you have to have the data. And we end up doing a lot of analysis with companies like that to really understand where they're having risky behavior, and then enable them to run programs at scale to target folks that need retraining and really concentrate their efforts so that they don't have to, for instance, retrain everybody that needs training. They can focus on a couple of the drivers and the ones that need help with specific types of behavior. So I'll show you a couple of examples like that. But our typical enterprise customers, and it sounds crazy, but they'll roll these out on probably a couple thousand devices. They will end up like this whole system running that out, doing the trainings and running the workflows at a global level will usually pay back within a year or two. And we see, we've had a bunch of companies that have gone through and do this. Our typical customer sees their accident rate drop somewhere between 50 and 75%, even as high as like 80 to 90%. And so the system just kind of like pays back for itself. So basically, we've like kind of aligned everything to make that possible, if that makes sense. And that's how we think through, should we develop a feature? What kind of technology can we bring to the table to drive a reduction down like that? I'd say that the second part, and this is back to our mission costs, are these similar types of like, taking the data out from the field, running workflows back in the cloud to help them like understand where they're, it's kind of like running a profile on a program at an organization level. They need to actually just be able to target where those expenses are. We see similar kinds of improvements on fuel costs and other things. Usually fuel costs for these expenses for companies that have thousands of vehicles are in the tens and hundreds of millions of dollars. And so what we've ended up finding with them is if we can go through, get them data to understand like how much idling are they doing. And everybody kind of ends up seeing this because if you see a larger vehicle that's like parked outside somewhere doing a delivery, and if they leave it on, it's just burning, fuel without any, there's no like benefit from it. So, if companies don't track that, there's no way to fix it. So a lot of our tooling ends up helping doing that. And then similarly doing coaching for drivers to let them understand like exactly like where they fit in, how they're doing, and then even do things like set up alerts for them. So that's a little bit about the system, and I will show you. So maybe I'll take a pause there. Does anybody have any kind of questions just overall about what we're trying to do, or who our customers are, who we serve? So one question was, I'm going to try to phrase it, so let me know if I don't get it right. What types of behaviors are the companies like trying to coach for? And I'll give you an example. Maybe a year ago, I went out to one of our customers. They're the largest chemical distributor in the U.S. It was really interesting because when I found out about them, I didn't know exactly even what, if you asked me like, what is chemical distribution? I was like, well, I couldn't actually elaborate exactly what they do or where they are. As I started to learn about them and get to know them, I realized like, in fact, they actually had a office probably 15 minutes. I live down in the Mid-Peninsula here in the Bay Area. Within 15 minutes of my house, they had a place. I went to visit it. It was really interesting. They actually have, I don't think I have a picture of it with me, but they would get chemicals delivered in by rail and then transfer them to tanks. And then they had a large set of trucks that would essentially deliver that out to their customers. Started to ask questions about like, well, who are you typically delivering to and things like that. It turns out actually that a company like that actually delivers and one of their largest, for them, their largest customers are actually like pool chemicals. So every pool at a university or a high school needs chlorine, and they have to fill a tank locally to be able to fill it. As a result, those drivers are coming in every day, filling their tanks up from those fuel containers, driving them out, like, in the communities to a place like Berkeley, and then doing a delivery wherever the pool would be. They have several things, and kind of what we've seen internally are there. And if you walk into an office like that, I think they had about 50 drivers at this location. They're out doing the deliveries. They're trained on everything from how to transfer stuff, from the tanks to their trucks. how to do deliveries, where those are. They have notes for every day. They have notes for going through and cleaning the tanks at the end of the day so that it'll be ready for a different type of chemical the next day. So kind of interesting because it puts it a little bit in the context of a lot of our stuff ends up focusing both on the road behaviors, if that makes sense. Then there's a whole other set of safety things and kind of workflow procedures to keep those workers safe when they're doing deliveries. On the road side, one interesting thing is we've seen a couple big things. A company like that, and what we've seen is those chemical distributors are some of the safest drivers that we see, which kind of makes sense. Any error for them is much different from someone that's out and might be driving like a Ford F-150 that's doing field services or might be doing deliveries or might be in construction. The consequences for a big tanker truck getting into an accident are just much different. So one interesting thing with those types of vehicles that we end up seeing, the behaviors are a little bit different. We don't see extreme speeding, if that makes sense, that we might see with if we go sample our other customers that are doing Ford F-150s and things like that. And most of those folks, when they're out, they don't have as large problems with the other larger ones are mobile use and then following distance. Those are kind of the three largest predictors, if that makes sense. But we end up measuring a lot of stuff, and I'll show you a couple examples of that. So to kind of make it concrete here, we have a demo set of demo customers of folks that have given us permissions, if that makes sense, to show a couple examples. So I will show you what this ends up looking like. So in this video, I'll pause it. This is essentially the coaching interface that we have back in, where some of these devices, the dash cam, has been installed in, and this in particular is actually an ambulance or EMS vehicle. You can see it on the right. There's the driver driving through the city. This is an event that got tagged as a harsh break. Back to so this was kind of like a near miss style of event that where we picked up stuff from the IMU and that kind of triggered. This video came from the dash cam on the edge. It got uploaded to the cloud, and then we binned it. And then they have a safety coach that has gone through and usually spends their time loading these events and then taking action based on, they'll review the event manually or we'll help them with some automated tools to do that. And then they'll decide what to do. Is like, does it need additional coaching? In this case, actually, the driver, they tagged it as you can see there on the right, needs recognition. And this is an interesting case. You can see this person's driving through. Here's the road vehicle. It comes to the intersection, the light green, and there is a police car that drives straight through, if that makes sense. So that's why they hit the brakes and patted. One of the interesting things, and this is kind of like one of the new things that we've started to develop, is actually have automated ways to make these kinds of judgments about whether this was something where it was like we needed to coach the driver on, or whether it was actually something that was positive behavior that we should recognize them, if that makes sense, because it's in a lot of these cases, actually, we need to go through and really think about both the carrot and the stick, if that makes sense, for these cases. But this is a really cool example because we've been able to tag this, use AI to make a little bit more of a judgment call about whether this was appropriate or not. And then we have ended up working on the mechanisms to go through, flag it, and then recognize these drivers and send either messages back to them saying like, hey, we saw this happen. I mean, because you can imagine if you're this driver and you saw this, like, you're going to be like, you wouldn't imagine the crazy thing that happened to me today. It's cool to be able to send them a note, or to be able to send a note to the broader team and say, hey, look, this person was out driving. Look at this crazy video we ended up catching. So it's kind of interesting to see that. But we basically have a really large analysis, and I think a lot of other companies have seen this too. There ends up being kind of a hierarchy of driving behaviors, obviously, that go through. The biggest one that we see correlated with risk is extreme speeding. If we tag that, that's usually the number one. We see quite a number of cell phone use that ends up being pretty correlated. It's just really hard and ends up drivers that end up picking up their phones and looking at it. It just obviously ends up being a pretty large issue. Those are the couple, and then but every company interestingly enough, ends up being a little bit different for wanting to understand what their policies are and how they set these, because the ambulance company actually just might end up with a very different set of things that they care about and drive safety outcomes for them versus some of the other companies like a chemical distribution company and things like that. So overall, like maybe this gives you a little bit idea of how the system works. So we have these safety administrators. They're usually like logging into our cloud system. They are looking through events that have been uploaded to the cloud. We're doing a lot of technology development to both run the detection algorithms at the edge for these, upload events that probably need more processing, and then we're doing a lot more in the cloud where we can aggregate all this stuff together, use much larger models to go through and do an analysis, both to like verify the things we see in these videos, as well as generate human parsable descriptions and things like that at a little bit of a higher level than we might be able to do. I think the other thing I wanted to talk about a little bit and give you guys a couple of examples. So what I've kind of shown you here is a single dash cam unit. We have seen, especially on larger vehicles and things like that, there's been kind of a proliferation of desire from the customers to get more visibility around the devices. So this unit here is actually like a multi-camera system so that they could go through and you can see it. I could make it cycle through, and it's actually got 4 cameras plugged into one. This is one of the newer units. It's an AI multicam unit. It has a bigger, beefier processor and larger GPU so that we can run more models. One thing we saw, especially with the heavy vehicles, is that kind of to tack onto your question, one of the largest accidents that we were not able to detect before, but we've heard through working with customers is a really big case, is when they're backing up. At very low speeds, it's actually one of the more common types of accidents. And so the multicam is really cool because it can let us do that and then start running AI algorithms at the edge to let them notify, like if it's a cement truck or something that's backing up, let them know or beep, if they are going to hit something or someone. So we've been working on this unit, and that's what you'll see here. But this enables kind of a much richer set of detections other than just having a dash cam out in the field. So that's kind of like one thing we've been working on. I think I will pause there and see if there are questions. I would be happy. I think some folks end up wanting to hear more about customers. Some folks end up wanting to hear more about kind of how we split some of our technology architecture and stuff like that. But I would love to hear kind of maybe get a sense from folks. If anybody has any questions or would love to hear about a particular area, I'm totally happy to talk about it or give some demos. Great.
Is there a sense that the drivers are driving more safely because they know they're being observed? And is there any kind of pushback from like customers? I guess if you're working for a company and you're told, oh, you have to use this system, it's a different thing. But there's I guess you're safer because you've been trained on these things, but you're also safer because you're being monitored.
Yeah, it's really interesting. And I think it's one of these things, like if without being out in the field and talking with a bunch of different folks, it's kind of hard to get a sense for it. There's 2 things going on. One is we usually end up partnering with these larger companies, and the nice thing about safety is it's hard. It's something everybody can get aligned on. If that makes sense. I think the nice thing is like drivers, they want to be safer. The companies, if they can get the reduction in accidents, it's meaningful for them. And then, us as a company too, like, I mean, it's very easy to understand like what it's like. I'd say 4 or 5 years ago, this did come up a lot, and we end up having to partner with companies. Usually when they're rolling out stuff, a lot of them are unionized too. So it's, quite a process to go through and talk to folks. I'd say one interesting thing with AI, people have gotten more comfortable than it was, and this has been a little bit of a shift, with the fact that like oh, there can be an AI review of this, I think it starts to make it feel less personal, if that makes, where I'd say if you were around like 5 years ago, people were like, oh, is this, what are the implications of someone being able to see what I'm doing? But if it's actually like all safety driven, it ends up being a little bit different. I'd say the other thing is, for the most part, on the fleets that we see, like the folks are professional drivers. And what we've seen in the field is they usually, in the first couple of weeks when there's a deployment or a trial of one of these things going on, there is some kind of exoneration event where having a video of what the driver did usually ends up for that driver showing that they weren't at fault. And when there's no data, it's just, person, whatever they say, no one can actually make heads or tails of it. When there's a video of what happened, they can go back and look at it, and it helps them. We've had crazy cases and heard from our customers, for instance, of people reporting in hit and runs. And I'm pretty sure if you go talk to folks that drive the buses in any of the major cities, that they all are like, please put a camera in, because people just will call in. There's no real cost sometimes in these, like, and the way the systems are set up for someone to go through and claim something happened. But if they can go back and review the footage, and it saves that driver from, having to deal with folks and stuff like that. We've had customers where police have shown up to arrest someone for a hit and run. And then, they go in, they pull the dash cam footage, and they're like, yeah, nothing happened. They could see in the intersection where, whoever reported it was clearly walking by, and there was another incident. So it's been kind of interesting. I think like all these things combined, like what we've seen is, like, as people go through it, we kind of have to just stair step it, partner with our customers to go through and like really work with them to show the benefits. And ultimately, like, a technology like this has to be beneficial, for all the people involved. But we've seen pretty big success cases with those things when we've gone through.
Just to be back on that question. A few years ago, Allstate, the insurance company, was here talking to the same AI group, and they painted this picture of sort of changing this good driver discount policies to ones where if you consented to having a dashboard camera, and the other thing that they said is probably a point about forensics. So if there was an accident, to not leave it to the lawyers to duke it out, but to have this video evidence, just like the thing that you said about the hit and run. So what is your take? I mean, in terms of, it's really limitless. I mean, you're applying it to professional drivers, but if you incentivize people to get lower insurance rates if they consent to have a dashboard cam, that's what Allstate talked about. Are you seeing this among your customers about that sort of?
Yeah, and the way I'd phrase it is, most of the time our customers are and I'll repeat the question, like, for folks, like, I think, are we seeing there being incentives, or could there be incentives in various driver systems for people to install these devices? I would say for the customers that we have, it's a little bit different than, because they're all larger enterprises, a little bit different than consumer. And there have been a bunch of like data, really interesting data consumer companies that have even either getting discounts for telematics devices or for putting those in. Probably a large chunk, and I wouldn't get the answer right. When you end up having tens of thousands of vehicles, you're self-insured, usually at that scale. And so, because they're basically like running their own insurance company. If we go talk to those customers, it's really fascinating. They have whole risks. They have whole departments of they're internally hiring risk analysis folks. They probably have a couple data scientists involved, and they are doing these type of analysis themselves. Usually because they will have, they have some specific workflow that they're doing that might be a little bit different from everyone else. And they need to go through and actually understand where the riskiest behavior is for them to drive that number down. And it makes sense economically for them to hire a small group of people, because the costs of hiring that group of people to do the analysis and then make the policy changes internally will pay for itself in the accident reduction case, if that makes sense. So these are essentially, those larger enterprises are mini insurance companies internally. And so I think that's one way we're able to align for it. We have seen a pretty big uptake, and a lot of the for the smaller companies that might not be possible, and it might not make sense to hire the experts internally. They usually will get insurance from outside groups, and we have seen a lot of folks end up basically having discounts for it because the insurance companies, if they can, get a reduction, they're essentially going to encourage the same type of behavior. So we have seen a lot of that. It's totally fascinating to see. I think this is one of the areas that I did not appreciate when we started getting into the space, that like actually having everybody kind of the points aligned around safety is really helpful, if that makes sense, because there end up being a lot of stakeholders when you're going out and like looking at an operation like this. There's the company, there's the drivers, and there's also the manufacturer. It's actually amazing to have it all. Everybody's incentive is aligned on the safety piece, because it's such a easy one to drive actual changes and outcomes for.
So you mentioned like that you're able to run larger models in the cloud, as well as like some smaller models just on device. Can you talk about the differences between the two and what sort of larger models you're able to run in the cloud?
Yeah, absolutely. So I won't repeat the question because I think it came through on the mic. One really interesting thing is like, so this AI dash cam, I'd say, just to give you a little bit of perspective, this is the one of our first hardware devices that has video transformer models that are capable of running at the edge. So we're really excited about that. In general, what we've ended up seeing is that the models and the hardware trails probably like 2 to 4 years behind what's available in the cloud. So I kind of think everything that, if we look at one of the larger NVIDIA systems, if that makes sense, like that needs to make its way out into the smaller devices that are a little bit more energy efficient, that can be deployed in a smaller footprint and aren't going to be as expensive as the ones that might be in the data center. What we'll end up doing, and I think one good example is, I showed you one of the hearts event videos. Another example would be like if we're doing some type of multimodal crash detection, is a good example just to kind of like walk through a system and how it could be constructed. Obviously, we would love just to warn the driver before there's a potential accident, just to give them a heads up, if that makes sense, via audio alert or something like that. If we can do that, that's amazing. That's kind of detecting like hey, just one bit, like an event happened or event might be about to happen. If we can do that at the edge and then flag it, that might be like it's feasible to build a smaller model to do that. We can work on the precision and recall that we need to get to feel like it makes sense to do it at the edge. Once we flag that, we can send it up to the back end. We can actually do a much deeper analysis, and it doesn't necessarily need to happen in real time. So the stuff at the edge, if we need to make an alert like that, we actually have to get that model to be able to run somewhere probably between on a video segment in 100 milliseconds to 250 milliseconds in order to provide an audio alert when it happens. Once we send something up to the cloud, you can imagine that maybe we're not going to just do classification, if that makes sense, but we might want to actually go through and, we might not just want to flag if the event happened or not. We also might want to do a more advanced classification. We might want to run more advanced segmentation models or do other things, and we might want to do scene understanding, like I just showed you. That actually, we might take minutes, to do that analysis. It's not nearly as time critical. We can also go through and tell, like maybe it was an event, but maybe we run a more accurate model on the back end that takes many more resources and might filter out some number of events. So we can kind of pair those models together to end up making a very accurate inbox for the safety managers, if that makes sense, where we've gone through and done some processing staging, essentially between the front end and the back end. So those are kind of examples. The ones that run in the back end, I mean, there we have almost any possible model and what feels like, compared to the edge, an infinite amount of compute that we can throw at those devices. So it ends up changing what we're able to present, because we won't get a scene description necessarily. I think we will, if we fast forward in 2 to 4 years, we'll start to get hardware that's much more capable and that we're able to do this stuff at the device and make much more custom detectors. But right now where it is, like that's kind of the architecture and how we've been splitting into.
Can you talk about some of like the model compression that you're running to be able to run it on like a constrained device? Like, are you quantizing the models that you're running, or is there any other special algorithms that you're using?
Yeah, that's right. So one interesting thing, we end up with a bunch of different hardware pieces, right? And we have a series of detections that we want to run. Some of the hardware has more and less compute, and we essentially have a very, very large offline data set that we've collected from these devices that we can go through and take one of our models. We can distill it down in some of our pipelines, and we might distill it to a couple different architectures, and then we'll simulate it and look at the performance on the large data set that we have. It ends up being quite challenging to do, and I don't think this is really any different than like a lot of the other companies that are doing things like in self-driving and things like that. But I can tell you, we see driving conditions in June and July are very different than the ones that we see in December, just because of ice and snow and stuff like that. If you look at the videos and the data sets, they look actually very different. So we have to more or less have a really good representative data set. And we have teams of folks that go through and actually do this and try to make sure that our data sets are representative of the environments that we actually see out in the field. Once we have those data sets, we actually have a pipeline, and we run a bunch of different, we take each model kind of detection, distill it down, and then run it on these larger ones and try to get them to be as close as we can. But the interesting thing, kind of to your point earlier, is that like actually the precision and recall are a little bit different what we're looking for on the models that can run in the back end versus the firmware versus down on the embedded devices. But yeah, for every device is a little bit different because sometimes they have different hardware capabilities. So what we're able and how we do the quantization ends up being a little bit different for every device, but we more or less have a pipeline for going through, distilling it down, and then looking at the performance of them. The interesting thing from our perspective is that I think we've been relatively agnostic to a bunch of the techniques, because if we have an offline data set, then we can just make it very cheap to try a bunch of different things, see how well those perform on the stuff we have, and then make a decision after that. So I can tell you, like, some of the hardware has certain capabilities that we've ended up using quite a bit, but there's a lot of particular engineering that goes into like trying to figure out what ideas for quantization and stuff like that.
You mentioned there are different type of customers you have with varying requirements, like the chemical distribution one. How does the timeline work? How often do you guys customize the software and the hardware? Do they come to you and there's like a couple months of trialing, or how do the machines you already have adapt to the new software that's needed for the new requirements?
Yeah, it's great question. So one really interesting thing is that I think, especially when we got started, we didn't know how widely applicable a lot of this stuff would end up being. And there was a real question, and this is some of the stuff you get into of, are you to build a real scalable business, you can't. It's very hard, and I mean, some folks are able to do it. Build a consulting group, right, that actually is doing different work for every customer. The hard thing about that is, obviously, like if you're doing custom work for every customer, like you're going to be limited by how much bandwidth you have. I think what we've ended up seeing is that actually the safety stuff is pretty consistent across all of the larger fleets and the types of things that they want to see, whether it's like reducing mobile use. And we can find studies, and we've done this internally and correlated with outside groups, is just like, what is the list of risky behaviors, and then sorting it and going down that. Just to give you an example, one of the biggest ones that we ended up working on last year was drowsy driving detection. Much more complex model because it's not just like detecting if there's a mobile phone present, if that makes sense. You're actually needing to like look at a face, understanding if they're, are they yawning or blinking, and kind of there's a lot of that's very ambiguous. The more advanced models have gotten much better at this, and we couldn't have even imagined doing a feature like that if we were going like 5 years ago. But it's possible. I'd say a feature like that, we know it's going to be broadly applicable, if that makes sense. What we have seen, and I'll give you a really interesting example. We've been working with a customer. They're another EMS customer, like I just showed you. They end up with they have enough drivers that their most severe incidents sometimes are leaving passengers behind in the vehicles. And so we started, which, obviously they're just like by the description would be a terrible thing, especially if they're delivering a patient. We talked to them and their business team, and we ended up basically like trying to come up with a generic enough solution that we could build a little bit of customization on top of it and then reuse it, try to figure out some way we can reuse some technology like that for a lot of different customers. So I think this is one of those interesting examples where the architecture really matters for how we would build a feature like this. And if we can construct it in a way where we can end up reusing that across a bunch of different places, it'd be really interesting. So, giving that as an example, we started trying to figure out like, hey, is it that at the end of a trip, can we detect that, use that as a trigger, take an image, and then send it to the back end and maybe have some custom logic that's built on top of a LLM or something like that we work with the customer with to let them do that piece of the customization that might be different from other customers. But it's obviously an application that once we started talking to many other customers, they have similar types of customization they want to do. So I'd say that's a case for where our product and engineering architects spend an awful lot of time trying to like figure out how to construct a system that would be more applicable and wouldn't just be custom one-off stuff. But really interesting example, and I think another good one of like a safety situation, if that makes sense, that like is kind of related to a bunch of the on the road stuff, but a little bit adjacent.
And I had another question, similar to what she asked. What do you think the percentage of improvement is coming from the drivers know that they watched? And you mentioned coaching. What does that entail? Obviously, you don't need to tell to not look at their phone or don't brake harshly to them. Like, what does the coaching entail?
Yeah, and I'd say this is one of those things. It's just our largest trials usually when we do them. What we actually do with the customers is deploy the devices first. They let it set for 2 weeks because usually what we had seen internally is that immediately when you put a dash cam in there, even if you don't turn it on, their behavior gets good. It takes a couple weeks for them to kind of go back to the baseline, if that makes sense. So we basically end up internally being very sophisticated about working with our customers to make sure that we see the A/B test, and that's where we do see we can kind of do a cohort analysis of when we run the things out about actually understanding how it changes the behavior, and then also we can kind of install them without actually doing the detections, if that makes sense, and then turn those detections on to actually do do as good of an A/B test between them. Oftentimes we'll do that with customers, and that's where we see it is a pretty big reduction. It's probably like 75%. And part of it is, I'll be honest, running the same thing. If I run this, I would love to think that I'm like a perfect driver. And then, but it's different. Like when, have the thing beep on me, I'm like, oh yeah, I was totally using my cell phone. I just like unconsciously did it because we're so used to in our lives, like having them around and not even thinking about when we pick them up. So I think actually getting the alerts and the coaching is pretty important and drives a lot of the behavior changes.
Thank you.
What are some surprising outcomes or challenges or even disadvantages to implementing this system?
Yeah, I think. Let me think about that for just a second. I think one hard thing with these, it's really tricky to figure out what to do on the edge and then the back end, and how to pair those together. One interesting thing for this, I mean, we have a cell modem in the devices, so they can upload the data, but we obviously can't turn that on all the time because it's actually expensive. That makes sense. I think there's a really tricky thing to go through and do and try to figure out like how much can we push to the edge, and then do how much can we actually just do on the back end, if that makes sense. And I think it's kind of a constant evolution of trying to go back and forth between pushing, getting as much smarts as we can on the edge, but then some new technique comes out where like we will usually try it out in the back end first. and then start architecting it and getting it possible to run on the devices. But it's usually a little bit different. I mean, there's stuff now that we're doing on the edge, like even drowsy driving detection, that I think if we were around 5 or 10 years ago, it was impossible to imagine. It was hard to think about doing a technology like that on the edge, and you would need a huge amount of compute to be able to do it. But the combination of both the techniques everybody's figuring out how to be more efficient across the board, and the hardware is actually just improving over time. So I think some of the decisions have just been changing on how we would architect the systems. But yeah.
What about in terms of the workers or the companies?
Yeah, good question. I'd say probably for them, usually it's we have to go out and spend an awful lot of time trying to figure out what would actually move the needles for the companies, because it's easy for like even myself to just assume, if that makes sense, that something would be useful. I feel like I've learned a lot and I think I was talking about this earlier, going out and getting embedded with the customer and then finding out what keeps them up at night. So that might be going and finding that risk analysis group inside of a big enterprise customer, because they actually have a lot of the data to know what would drive better safety outcomes for them. And then taking that back on the technology side and trying to figure out, well, how could we actually detect those events? Give you another example. I mean, I talked about this was like a hardware solution that I talked about for detecting if folks are backing up or backing into things. But we've had a lot of customers that actually have the same things. They have policies on how they will park in parking lots. So if you imagine a Ford F-150 truck, some folks actually mandate that they pull back into spots so that they avoid in the morning when they're leaving backing out of the spot, because that ends up being more dangerous than not. That's kind of an interesting example. Like I just wouldn't have, it wasn't even in my realm of possibilities that would help drive a safety outcome, if that makes sense. Only with getting out in the field and talking to customers and hearing from the folks that they're like, well, it turns out half of our accidents today, because they had already driven a lot of reductions in their events, were related to this. So trying to help them figure out, like, if that company can make a policy internally for their drivers about how to park in the spots, then we can take that back as a product example, if that makes sense. Because that means we need to be able to generate some kind of report for an organization like that shows, like, here's your drivers, here's how many like parked in the spots. I think and some of the other academic literature, usually this is called like adherence, if that makes sense, for like being able to say, like, if you had a policy, like, did you actually like enforce it? But some of those things are just like impossible to learn without actually like spending a lot of time with customers.
I have a quick question about data privacy and concerns that customers might have about that. Just a few in succession. Feel free to address any of them. Do you offer edge-only solutions for customers that are particularly concerned about their drivers' biometric information being processed on cloud? Do you offer, different cloud processing solutions for customers who are more or less concerned about privacy? Assuming that some of these drivers are driving across state lines, are there guardrails in place to be acting in accordance to data laws that differ state by state? Just some questions about this.
Yeah, so this is a really interesting area, and I mean, certainly there's a lot to talk about. One big thing, I think, because like we're what I would call like a pretty the cases that we're targeting are pretty straightforward. Like for us, when we talk to our customers and these big enterprise customers, we're like, oh, that data that we might collect, or that, like, where I was showing you examples in the dashboard, it's their data, if that makes sense. We're not, like, we're in the business of helping those enterprises, improve their safety and drive their costs down. That's aligned with it. We're not like selling to a third party, if that makes sense. So we basically treat the data and what they want to do with it is theirs. And that ends up kind of like cutting out a whole bunch of issues that might be the case. There are often regulations, and that may be per country, in some cases per state, that they, as operating the service, if that makes sense, and running these safety programs, might need to do, whether that's like different PII requirements or other things. So we end up actually having a lot of tools internally to help companies comply with those types of regulations, because there might be some places that where they need to have some, they may need to notify the drivers about the PII's stuff. They may need to set different policies based on where they're driving and things like that. We actually end up with a whole suite of tools that we've had to develop on the software side to help kind of enable those types of things. And then, of course, we end up actually, and I think it's one of the things about the enterprise, is like when you start, you can imagine if you have a group of 10,000 drivers, you're going to have actually a set of different policies, because maybe, several thousand of them are driving a particular type of truck, delivering certain types of goods. They may need a different set of policies for what they want to treat as safety, even for privacy stuff, than some of the other folks that might not need have as stringent requirements, if that makes sense. So there ends up being a lot. These are what I would call the true enterprise features, being able to support cases like this. But it's one thing that we spend a lot of time on. So maybe I'll take one more question and be happy to talk with folks. I think the other thing is, like, we are, I think I had a slide in here. Just wanted to focus on it. Like, we are recruiting quite a bit. Like, we've been hiring internally. We have a bunch of different teams that we're looking for folks looking for some folks with PhD experience, especially in data science, machine learning. Also, if folks are interested in firmware and hardware, we have a bunch of roles for things like that. And then we're looking for several interns for next summer. So, all right, great. So yeah, I'll break with that. But thank you, everyone.